Euclid's 13th proposition says that given a line segment, if we make another line segment stand on it or lean on it at some angle at a particular point or at any point. So let's form that line segment. Then the sum of these two angles is going to be equal to two right angles, or in other words 180 degree. So we have to prove that the sum of these two is 180 degree. Now to prove that, let's draw a line perpendicular to DC at B. We know how to draw a perpendicular. Draw a circle of any radius. Identify the intersections of the circle with the line DC. Say G and F. And now draw a circle with G as the center and GF as the radius. Similarly, another circle with F as the center and GF as the radius. And now these two circles will intersect. Identify the intersections. Connect those two intersections. Now we don't really have to connect those two intersections because we are only interested in this part. So we can connect E to P. And now that we have got the perpendicular line, now we can hide all these circles and the intersection. Okay. So now based on a definition, we know that angle DBCE is 90 degree and CBE is 90 degree. That means the sum of these two angles, that is CBE and EBD, is 180 degree. The sum. Individually, they are 90 degree. That is right angle. So keeping this in mind, we have to prove that CBA angle plus ABD is equal to two right angles, that is 180 degree. So let's see how we can do that. We know CBE plus EBD is 180 degree and they both are individually 90 degree. Okay? Now let's take it from both directions. If we take it right to left first, then angle CBA plus ABE plus EBD is equal to 180 degree. And if we take it left to right, then EBD plus ABE plus CBA is equal to 180 degree. Since they both, whether you take it left to right or right to left, the sum is 180 degree. That means we can equate both those two expressions. CBA plus ABE plus EBD is equal to EBD plus ABE plus CBA. Now, what we'll do is, we will, since they are both equal, let's manipulate that equality. What we'll do is CBA plus CBA plus ABE plus CBD. So these two angles we will take it together, or rather we will add it up to get CBE plus EBD. That would be equal to, now from the other side. Now we'll do what? We'll take these two angles, we'll sum it up. We will say EBD plus ABE is equal to ABD plus CBA is equal to 180 degree, or rather the other expression. Since there is equality, we can say CBE plus EBD is equal to ABD plus CBA. Yes, a bit tricky. Better you write it on a sheet of paper and try to figure it out. So we have shown that CBE plus EBD is equal to ABD plus CBA, and since CBE plus EBD is equal to 180 degree, we can say CBA plus ABD is equal to 180 degree, which is what we had to prove, that the sum of this angle and this angle is equal to 180. As usual, I have provided a link to a PDF book which describes the 48 propositions of Euclid's in his book, One of Elements. You can download it and have a look at it. That's it for now.